When you click an application, it feels like the program starts running. That's not what actually happens. A program can't start itself. It's just structured instructions stored on disk. The moment you click it, you're not activating the program directly. You're making a request, and that request goes somewhere specific. Let's walk step by step through what truly happens between clicking an app and the first instruction being executed. Before execution begins, a program lives in long-term storage, your disk. It is stored as structured instructions, but it is inactive. It is not in working memory. It is not being read by the processor. It is simply sitting there. This is important. Software at rest has no behavior. It only exists as stored structure. Behavior requires movement into working memory. Until that happens, nothing is happening. The operating system is the manager of the entire machine. It is not the CPU. It does not execute your code. Instead, it controls who gets memory, who gets processor time, and who is allowed to run. Think of it as the authority that organizes the system. Without this manager, every program would compete directly for memory and execution. They would override each other's data and crash constantly. The operating system prevents that. It organizes resources. It enforces boundaries. And when you click a program, it is the operating system that decides what happens next. When you click the program, you send a request to the operating system, not to the processor. The operating system receives the request and evaluates it. Do you have permission? Are resources available? Can memory be assigned? Execution does not begin automatically. It begins after approval. That approval step is invisible, but foundational. If the request is approved, the operating system reserves space in working memory for the program. That space is separate from other programs. This separation prevents interference. The operating system also keeps track of which program owns which memory region. That ownership is essential for stability. Without it, programs would override each other. Now, the program's instructions are copied from storage into working memory. The processor can only execute instructions that exist in working memory. Once copied, the program is no longer just a stored file. It now exists inside the machine's active space. But still, it has not started running. The stage is prepared first. This is the key transition. A program on disk is just stored instructions. But once loaded into working memory, it becomes something active, a process. A process has reserved memory. It has boundaries. It has a life cycle. That transformation is orchestrated entirely by the operating system. Without that management layer, execution could not begin safely. Only after memory is assigned and instructions are loaded does execution begin. The operating system schedules the process, and the processor starts reading instructions from working memory. Notice the order: request, approval, memory assignment, instruction loading, scheduling, then execution. Execution is the final step, not the first, and every step before execution creates isolation. In the next video, we'll explore why that isolation is what makes reasoning about software possible at all.